a band-limited system, if we want to increase the data rate, we have to increase the number of pulses transmitted every second. This implies that the symbol duration tau will have to be decreased. A decrease in the time period tau indicates an increase in the frequency requirement 1 upon tau.
Okay.
That is, bandwidth increases. If the channel is band limited, this increase in the bandwidth may overlap with the neighboring channels, leading to intersymbol interference, that is ISI.
Then how do I overcome this ISI?
To mitigate ISI, Nyquist suggested that the theoretical minimum bandwidth needed for transmission of RB symbols per second is RB by 2 Hz. And when a pulse is transmitted through a channel with sufficient bandwidth, in order to maintain zero ISI, it must satisfy the following condition, that the pulse should be 1 at sampling instant 0 and should be equal to 0 for all other integral multiples of bit period TB.
The red filled in areas of the eye diagram represent the eye openings. And obviously different data patterns, as we can see here, different data patterns give us different eye openings. So why is this important? Well, for a robust system, we want as large an eye opening as possible. But one of the things we see is that as the data pattern becomes more realistic, more closer to a random pattern, for example, if we think back to 4, which was a mixture of low frequency and high frequency data, which is what we would expect, our eye opening gets smaller and smaller. In these patterns, we have a very finite number of trajectories, a finite number of patterns, and we can see that we have these well-defined blue lines. But in a real random data pattern, we don't have these very particular data patterns. We have all kinds of data patterns. And what that means is that instead of these well-defined trajectories, we get all the different types of trajectories in the middle of these, and that is really what we get how we get these fuzzy eyes. The fuzziness is fundamentally due to the random data patterns containing random frequency content, and these frequency content experiences a frequency-dependent loss, and that's how we get this fuzziness.
What is ISI? ISI is intersymbol interference, which is form of distortion of a signal in which one symbol interferes with subsequent symbol. Distortion is the alteration of the original shape. This is unwanted phenomenon, similar effect as noise. How it's happened? Wireless signal from a transmitter transmit via many different paths, and the signal arrive at the receiver at different time and causing bits to run into each other and thus cause inter-symbol interference. When and where it can be found? It can be found in wired and wireless communication. In wire system, ISI happen in fiber optic. Intersymbol interference or ISI is the spreading of a bit into adjacent bits period. Ideally, a bit would consist of a square wave that instantly reach peak output at the beginning of a bit period and drop instantly to 0 at the end of the period. The pulse is dispersed or spread out so that it overlaps into adjacent bit period. If this overlap is bad enough, the receiver cannot accurately detect the presence or absence of a bit. This dispersion increases as the link distance increases. The type of dispersion in optical fiber. Chromatic dispersion. Chromatic dispersion describes the tendency for different wavelengths to travel at different speed in a fiber. A light source is rarely pure, in that it is actually a composition of wavelengths of various intensities surrounding a central wavelength. If operated at wavelength Where chromatic optical fiber dispersion is high, optical pulse tend to broaden as a function of time or distance and cause intersymbol interference. In wireless system, ISI happen because of multipath propagation. The multipath involves scattering, line of sight, reflection, diffraction, and its impact is an overlapping of two symbols. Since the various paths can be of different length, this results in the different version of the signal arriving at the receiver at different time. The various paths often distort the amplitude and or pace of the signal, thereby causing further interference with the received signal.
The effect to the signal is negative. The ISI is unwanted phenomenon. The effect include communication less reliable, error performance of the communication system. How to overcome or reduce the ISI? They have several ways, which is: first, band limited channels; second, separate symbol in time with cut period; third, apply an equalizer at the receiver that attempt to undo the effect of the channel by applying an inverse filter. The techniques such as equivalent discrete time model, zero forcing equalizer, MMSE equalizer, LS equalizer. Fourth, apply an error sequence detector at the receiver that attempt to estimate the sequence of transmitted symbol using Bitterbyte algorithm. Fifth, coded modulation system control amount of ISI into the system at the transmitter side is faster than Nyquist signaling. Lastly, in fiber communication, it is desirable to operate at wavelength where the fiber optic chronomatical dispersion is small or use light source such as laser technology, which is consists of only a few wavelengths.